Dear colleagues, it's our great pleasure to greet all the participants of the conference and give special thanks to its organizers. Our team is represented by two chairs of Mariupol State University. I am Olena Pavlenko, the Dean of the Faculty of Foreign Languages, Doctor of Philology Professor. And my partner is Iryna Tymofieieva, candidate of Pedagogical Science, Associate Professor of the Department of Pedagogy and Education. We are going to present a report entitled Search Query Data Analysis, Challenges and Opportunities. Search engines are currently recognized not only as a complex of information storage programs equipped with an advanced reference search engine, but also as a dominant statistical and analytical systems. The underlying assumption in this case is the experience of the popular Google Trend service, respectively owned by Google. The advantage of this service is not only in identifying the most stable popular queries in general, which can be obtained with the help of most traditional internet search engines, but also in obtaining statistics for a short period of time, the last 24 hours or a specified period of time in the past. In the last decade, there has been a flurry of work on evaluating information extraction systems based on a performance problem, but the methods above do not prove to be sufficient for systems. In addition, for ease of use, we must consider such aspects as scalability, availability, and interoperability. Using computers to understand and operate natural language text to perform useful things and desired assignments has become quite prominent due to the enormous increase of the World Wide Web and digital libraries. Following this, the article describing methods and basic issues of normalizing the text is of great theoretical value for our research. For example, Google Trend Service involves conducting a vertical search of 24 thematic categories and 1030 subheadings. Unfortunately, they cover the most common consumers' needs, such as vehicles or business and industry, but fail to sail a search area for neuroscientific, social, and especially library science issues. From the science column, the service distinguishes only 11 subsections related only to natural science disciplines, scientific equipment and scientific organizations. We can search multivalent words used both in library science as well as in other disciplines by referring to the text that pop up when typing a word in the search box. Thus, you can search the word library just clicking on the tag. Search query, topic, programming, public library system. In their works, the research in traditional Internet Explorer is not, however, completely suitable for metadata creation because semantic tags need to be mapped to instances of concepts, attributes, or relations, and this is not always a straightforward process. While researching the problem, we based on the article which described the construction of a new algorithm for embedding words. Most word-embedding algorithms only use the word pair that occur in the corpus, that is positive example, and maximize the similarity of those word vectors based on how frequent they co-occur. This can result in concentration effect. Word clusters from totally different topics can be placed somewhat close to each other. There are lots of possible word pairs that never co-occur in the corpus or they co-occur insignificantly, which we call negative examples. We argue that minimizing the similarity of negative examples is also crucial for the quality of the final embedding and results. In a better distribution of words in the latent space, our first major contribution is to design an optimization framework that exploits the full capacity of negative examples in order to push unrelated words away from each other, which leads to a better use of the latent space and improve the distribution of words. Our second major contribution is that we incorporate a kernelized weighing scheme for the negative example, where their influence in the optimization is proportionate to their kernel similarity with the word. We also stir our priorities to support the researchers' ideas that the ability to plug and play is an essential step in standardization. Having the ability to plug outputs and inputs in a query language incentivizes its adoption, simplifies abstractions, users do not have to think about multiple data models during the query process, and increases its productivity by facilitating reuse and decomposition of queries. These researchers provide the evidence to conclude that basic graph query consists of a single construct clause followed by one match clause. Current query languages do not provide full composability because they output tables of values, nodes, or edges. In view of the conductive analysis, we assume that the set of used approaches cannot claim to be versatile, and such optimization remains an actual task. One of the main goals of this paper is to provide a formal definition of the syntax and semantics of the graph query language, including the features shown in the previous sections. User search queries become the most important source of information for Internet resource owners. Since the findings of the analysis of such queries can potentially improve the quality of the search, as they help to better understand the interests of users. However, taking into account the knowledge gained, search engines will show the most relevant documents to the user. One of the main problems in analyzing relevant documents in analyzing search queries is the ambiguity of the word used in them. One classic example of this ambiguity is Jaguar query. In this case, it is unclear what information were the users looking for, about cars or animals. If we have knowledge about the interests of the user who entered an ambiguous request, we can easily determine what kind of information he wanted to know. Keyword grouping is the division of keywords into homogeneous groups according to searching criteria aimed to increase the relevance between keywords and advertisements. As a result, the quality of advertising campaigns improves and the cost of an ad click decreases. We also, based on the research of Julia Kiselova, in particular on her work Methods of Grouping and Structural Search Queries and their Implementation, where the author asserts that when preparing advertising campaigns, grouping keywords takes a lot of time. Some experts use the one keyword, one ad group approach, which eliminates the need for grouping and saves time. Nevertheless, it is not always convenient in using, especially with a large number of low-frequency keywords. In the clustering of keywords, the division into semantic groups was performed, then the structure of the advertising campaign becomes more reasonable and easier to analyze. Keyword grouping consists of the following steps: loading a list of keywords into the program, breakdown of all keywords into unique words, marking the words on the basis you want to create a group, uploading result to a CSV file. So you can view the basic characteristic to mark a unique word given below. Grouping is necessary when creating new internet sites, as well as when reorganizing and the structure and optimizing existing websites. It is also used when creating and conducting contextual advertising campaigns. The objectives of the grouping are cleaning the semantic core of an inappropriate keywords, grouping keywords to create the site structure of contextual ads, a better understanding of user intentions for ambiguous search queries, the selection of regional, commercial, and other specific types of search queries, combining in one group search queries that differ greatly in spelling but are identical in content or intention of the user, assessment of the need to separate similar search queries into different groups for separate promotion due to high competition, other tasks that require combination of keywords in groups, implying the same intention of the user searching the search engine for keywords above. Accordingly, the coincidence in the search results for two different requests in the first issued places means much more than the coincidence in the 20-30 places. You can view hyperbolic function on the slide below. The coincidence of URLs depending on their position can be represented as a function that is shown below. In this paper, we investigated the issue of clustering word grouping analysis with clarification of temporary expressions and semantic links. We suggested comparing the search query based on semantic proximity, identified as the distance between vectors, One of the fundamental characteristic features of our method is that unlike SGNS, which uses each entry in the matrix to upload and update the search word, our algorithm updates the word vector by means of semantic proximity based on its entire role in the matrix. The most time-consuming part of our algorithm comes to be the calculation of lexical group divergence that requires a set of calculations based on the similarity of words. In search for the solution to the word similarity problem, we suggest a number of datasets containing pairs of words which a corresponding similarity index specified by a user. Adaptive approach to user information retrieval prevents the effects of concentration and advances the distribution of words in the final display of search results. Thank you very much for your attention.